Tim Bryant. I'm the field crop entomologist here at the Tidewater AREC. I started in this position in August of this past year. So I'm going to talk a little bit about kind of what has historically been done by the entomology program here, some of the things we're doing this year in my first field season, and then some of the things that we look forward to doing as part of the whole program that we're building. So anyone who has seen me talk at extension meetings all winter has seen this slide about 6,000 times, but I think it provides really good context for the reason that this position exists here at the Tidewater AREC. So Dr. Chappell mentioned the crops that are important to our stakeholders in this area, being soybeans, corn, peanuts, and cotton. And I have responsibilities across all these different crops and all of the different insect pests that may feed on them. So what I have here is just an estimate of how much it costs on average to manage insect pests across these different crops. And that's the cost of control to manage insects, as well as the cost associated with the loss from their feeding. So across all these crops, across the state of Virginia, that totals to be about $30.4 million in costs of managing insect pests across these crops. So my primary goal is basically just to make this a smaller number. So we're doing research that hopefully will allow us to manage insect pests a little bit more effectively. And then we're also hopefully presenting that to our stakeholders in a way that's accessible, and we're giving them tools that they can actually implement on their farm. So it's 50-50 research and extension. And the ultimate goal would be that everyone is a little bit better equipped to manage insect pests in these crops. So how do we do that? I was asked today to talk about integrated pest management, IPM for short. And that really is kind of the backbone of everything that we're going to try to do in my research and extension program. And this figure I did not make, but I think it encapsulates what IPM involves pretty well. At the bottom of the pyramid, just like an old food pyramid, these are the things that you would always be using. This is the biggest part of your diet in IPM, is these agronomic practices. And these are mostly things that are occurring before you ever plant a crop and an insect shows up in that field. So you're talking about things like crop rotation, planting date, planting a resistant variety or hybrid, preserving beneficial insects, things like that, that kind of all occur before you're actually dealing with an insect pest. And then because of the scale that we work in field crops, there's not a lot of hand labor, and it's at a large scale. So biological control, things like releasing beneficial insects like you may do in a greenhouse or in a specialty crop production system, are not as feasible in a row crop production system. So then we kind of jump up to the top of the pyramid here with chemical control. So it is the smallest part of the pyramid, in that it's supposed to sort of be the last resort. You make all these decisions early in the season or between seasons, and hopefully that limits pest populations in that field to the point where hopefully you wouldn't have to apply any kind of chemical at all. But we're not really dealing with an environment where things are kind of naturally kept in check in that way. So ultimately we do end up applying an insecticide more often than not. So part of what we do is develop best management practices for those uses of chemicals when we do need to do them. And then we also have transgenic technology both in corn and cotton that provides that plant some inherent insect production. And that's used widespread in corn and cotton in Virginia. But anytime something gets used across all the acreage that we have, it comes with issues, namely insect resistance. So these transgenic technologies kind of fall somewhere ambiguously on this pyramid, but it is an important part of what we do in monitoring the efficacy and of those technologies and then insect resistance to them. So everything I'm going to talk about hopefully fits nicely into this IPM framework. And the idea behind IPM is that you use all of these various strategies together, and it allows you to produce a better result than if you just used one of them in isolation without any of the other strategies. So I started in August of this past year, and one of my first tasks was to figure out what our stakeholders needed from me. So I spoke at a pile of different extension meetings over this past winter and conducted a needs assessment survey to determine what information people wanted from me, and what would be helpful for them to better manage insect pests. So this question just read, to more effectively manage insect pests, I would like more information on blank. And these were the top responses. So as expected, insecticide efficacy and resistance issues was about 42% of the responses. Insect scouting and monitoring was second, or sort of tied with things like conservation, biological control, and then cultural control strategies. So planting date, tillage, nutrient management, all that kind of stuff falls under that umbrella. And then a few other things that came out in the wash a little bit, but we're still there, were insect ecology and behavior. So when and where insects show up, how they interact with their environment, and then host plant resistance. So based on the results of this survey, and interactions with stakeholders and kind of that framework of IPM that we already had before I got here, these are kind of the key program focuses. And these are, again, are things that stakeholders have come to expect from the entomology program here at the Tidewater AREC. Some of the things from my own experience that I'm bringing here, and things we'll move forward to in the future. So those are optimizing agronomic decisions for IPM, understanding pest ecology and biology, insect monitoring, and then insecticide efficacy and resistance. So I'm just going to give a 10,000-foot view of kind of what we're doing in all these different facets. There's a lot of different insect pests that we work with across a few different crops. So we could sit here for 4 hours and I could tell you individual projects that we're working on this year. But hopefully what I'm going to do is just kind of give you a sense of the types of things that we do and how they fit into IPM and our goals for this program. So we'll start here with pest prevention or limitation, or agronomic decision making. So this is the bottom of our pyramid. And I'm really lucky in being an entomologist here at the Tidewater AREC, and that we have the state specialists for peanuts, soybeans, and cotton here. So it's very easy for us to collaborate. We have field space to do research. Our offices are right next door to each other. So this was kind of a natural place to start. And I think sometimes an underserved element of integrated pest management. So we have a few different projects going this year in collaboration with Jacob Forehand, who you just heard from, Hunter Frame, who's our cotton specialist, and then Carrie Ortel, our soybean specialist, who you'll hear from after me. Looking at various aspects of crop management that you wouldn't historically maybe think of as insect management, but may have an impact on an insect's occurrence in the field, how it interacts with that crop, its damage potential, maybe some aspect of those agronomic decisions improves your biological control that naturally occurs, all these kinds of things. So we have projects looking at cotton fertility and plant growth regulation, peanut planting date and variety selection, and then looking at cover crop composition, effect on thrips. These are just a few of the things that we're working on, namely in collaboration with other faculty here at the AREC. So moving up the IPM pyramid here a little bit, this is the pest ecology and biology part of what we hope to do. And a lot of this is understanding where and when pests occur, and how they interact with their environment once they are there. So this is looking at things like species compositions. So for example, there's a host of different species of stink bugs that feed on basically every crop that we work with. And understanding which of those stink bug species is occurring is important for properly managing them. So looking at species compositions, looking at how they're spatially distributed within that field. So stink bugs, again, is a good example. Oftentimes they're aggregated on the edge of the field. So if we can better understand where they most commonly occur, maybe we can target our management more specifically to those areas of the field rather than spraying an entire field and spending obviously all those application costs to do so. And then the final piece of this would be the interaction of these pests with other pests. So they don't occur in isolation. We'll go back to the stink bug example. So stink bugs is the pest of soybeans, and then corn earworm. So seeing how those co-occur, if feeding from one makes damage from the other worse, if it drives it away, understanding those interactions is not necessarily always going to lead you directly to a management system that you could implement, but it is an important part of kind of understanding how the pest occurs, and hopefully leads you down the road to where you would develop a management strategy at some point based on that. So then interactions of pests with beneficial insects and their environment, which in this case would be namely their host plant, so corn, cotton, peanuts, and soybean. So some of the things that we're working on this year in particular to kind of improve our understanding of pest ecology is improving our monitoring for a couple of key pests. So one of those is corn earworm, which is primarily a migratory pest. So it flies north each year from southern regions where it can overwinter, and then it lays its eggs on various crops, and those larvae feed, and that's an economic issue. So we got some funding from the Virginia Soybean Board to distribute these white mesh traps. I don't know if y'all can see the pointer there. And those have been established all over the state. And we built this web tool to provide that data directly to our growers. And hopefully what they can do is look at the moth capture numbers and then know in that immediate area, it's time to go and initiate a scouting or initiate management for this important pest. So that's sort of an existing pest. And in the world of entomology, there's always something new popping up. So over the past few years, Asiatic garden beetle has been a sort of a sporadic pest of cotton in the southeastern part of the state. So that's been something we've been monitoring. We've got funding from Cotton Incorporated to work on that. And we've been working with a lot of our growers that we work closely with to monitor for that over the past couple of years. And I'll also mention here, I sort of touched on it, but half of my job is research and half is extension. So the through line throughout everything that I'm talking about is an ability to present that information to our growers. So we do that through kind of traditional extension publications, like we did here for the garden beetle, as well as through social media, hopefully making some videos about some of these pest issues here in the near future. So whatever we can do to get that information out. And then we get to the top of the pyramid, to chemical control. So best laid plans of mice and men. You've selected the right variety, you planted everything on time, you preserved your beneficial insects for as long as possible. Ultimately, pests are still going to reach the economic threshold, and you're going to have to go and make an insecticide application in many cases. So there's a few key questions associated with that chemical control. Just a few of them here is first and foremost, which products work. So basic insecticide efficacy is something we're doing across a number of pests in all of our crops basically every year. And then we're looking at how effective economic thresholds are compared to calendar-based sprays or growth stage-based sprays. When you can stop managing pests. So at what point in the season is it no longer economically valuable for you to protect that crop from those pests? So chemical control is, you know, it's an easy thing to implement, but there are a lot of decisions that go along with it for it to be highly effective. So those are some of the questions that we try to answer. And another big piece of chemical control is that anytime we're using something frequently, pests are going to develop resistance to that strategy, sometimes relatively quickly. So you can see in this figure in the bottom left, we've been doing corn earworm resistance monitoring since 2003, which was 2 entomologists ago in my position. And we're continuing that to this day. And then thrips is another major pest in cotton and peanut. And we've been working a good bit this year with trying to determine which insecticides are still effective for those pests. And all of this is kind of done through real world monitoring in the fields, through insecticide efficacy tests, as well as in the lab. And a lot of that is done in collaboration with faculty here at Virginia Tech and at other universities. Which leads me into this slide on all the collaborations. So everything that I've talked about, basically everything is done in collaboration with somebody somewhere, whether it's other faculty here at the AREC, other faculty in the Southeast region of the US, which is relatively similar to us here in Virginia. And there's a working group of entomologists in the Southeast that establishes objectives every year through multi-state working groups that encompasses corn and soybean specialists from states throughout the entire US. Everything is done with a regional perspective in mind, and with faculty at other universities. So we're always open to collaborations. A lot of these studies that we do only get more relevant when we're spread across a wider geographic range, and the data only becomes more valuable to our stakeholders. So that's some of the things that we're doing currently, or will be working on in the future. And that is all I have for y'all. Thank you.
Mr. Carey real quick, and she's